Okay, so like this. Okay, beautiful. Close 2D. Now it's better. Continue, please. And can we hit the well? Okay, good. So we are looking at the ester aqueous phase, Now let's check also the ester component there. The distribution is essentially the same for ester aqueous phase and the hydrophobic phase, because the two components are in dynamic equilibrium. Now let's check also the graph. Oil rate, water rate, okay, and then already the injection rate. The well was left producing for a year, okay, this until the injection test, because we want to, simulate the development of this field. Okay, and you can see a spike in water production rate because we inject something. And then we can also go to analytics, not ratio, expand, or maybe this one component water molar rate actually. Okay, you can show, uncheck everything first. You can show the water and then alcohol and then acid and then ester aqueous phase. Okay. In particular, we are interested in the alcohol and then ester aqueous phase. You can see the peaks there. Maximize. Okay, if I maximize again. So they peak at different times. So this one is at, 2020 May. This one is June. So they achieve the peak at different time, and from that difference of the gap between the peak times, we can calculate the residual oil saturation. Actually, we have the formula, the calculation, the equation to calculate the residual oil saturation from the gap between the two peaks, but I will not talk about that in this particular video. The physics of it, I will just show you the calculation or the simulation, I mean. Okay, I think that's all basically. So the main point here is to show you that we indeed can inject chemical tracer, you can say the chemical tracer, and it will involve in chemical reactions in this reservoir. In particular, we have 3 sets of reaction. So you can see here the ester aqueous phase. Okay. At some point we have high molar density, but later on it will disappear because it will be consumed in reaction, right? Something like this. Interesting. Okay. First, the concentration increases, but later it decreases because of reaction. And some of it will be produced also. Okay. And that's for what about molar injection rate? Yeah, I think this one. But that's not the main thing. Actually, we can again calculate the residual oil saturation from this, the gap between the two peaks. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next tNavigator videos. Thank you.